Check. Check, 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 check. Ladies and gentlemen, welcome to Chadev. That's right, Chadev Live. Here we are, live and direct, coming to you from Chattanooga, Tennessee. All right, quickly. Next week we have lightning talks, so you get 5 minutes to hold people's attention if you can. Usually people don't boo you off, so it's a pretty friendly crowd. So I think right now on the books we have one person for lightning talks, and we need like 5 more. So if you're interested, come talk to me afterward, and I'll put you on the list, and you can have your 5 minutes of fame and glory and forever be remembered in the annals of Chadev. The week after next, we are looking for a speaker. So the week after Lightning Talks, that's for a full session. You get 45 minutes there. If you've never done it before and you're not sure what to talk about, come talk to me. I can help out with that. Otherwise, yeah, we're pretty much open for the rest of February and March. So if you feel like you need a longer time horizon than 2 weeks would provide, then just come talk to me and we'll get you on the books, and that'll be a nice little bit of pressure for you to like get your talk together, and you know, for March or April or whenever that might be. We want to have you up here. Okay, so that's really about it. I think most all of you know Wil. If you don't, you're about to. Wil is a local web developer, programmer here in town, and yeah, he's going to talk to us about this stuff. Everybody give it up for Wil.
Hello, hello. All right, I think this is my first time giving a talk at the Etny building. It's kind of nice here. I like the lights shining in my eyes. And I suggest to anyone, if you haven't given a talk, you should try to. The Lightning Talks is a great way to kind of try it out, but also it's a great way to set yourself up for a topic that you know nothing about, and then force yourself to learn about it in order to give a talk about it. And so today we're talking about mental development tools, something that a little bit ago I knew nothing about. And it is a terrible title. I thought of a lot of better ones, Learning for Fun and Profit, but that everyone uses the for fun and profit. I mean, and if you need a title for your talk, just whatever it's about, and then for fun and profit, and people will like it. It's thinking about thinking, thinking about learning, but a disclaimer, I am not a psychologist. Not in any way, shape, or form, although I doubt many of you know who this guy is. He's a TV psychologist. He's not actually a psychologist in real life either. Thank you. The ideas here are not necessarily my own entirely, and they are just one perspective from someone who has been learning about this realm that we're going to talk about. So anything I say, take it with a grain of salt, and think about it not necessarily as being right, but being a way to think about things, and to get you thinking about things. And so what are we going to talk about? We're going to talk about how you learn. So everyone learns all the time. You have to learn new things, especially if you're a developer or a designer, or just about anybody in life, especially these days. You have to be learning. Your clients, most of you have some kind of client that has to learn what you make. And so learning is important to those people. And we all think of, you know, learning can be fun. That's why you're here, hopefully, is to learn something, or the pizza, one or the other. But learning can also be horrible. We all know a time where one subject or one thought, one idea in school or college just didn't jive with our view of the world, and we couldn't figure it out. There were troubles in that area. But why is learning sometimes hard, sometimes easy? What makes the difference in that kind of learning? And so let's think about some things. You know, algebra is hard to learn for a lot of people. Now, most of us should be past that, and probably, you know, there's probably a lot of us math geeks here, so maybe we didn't have trouble with algebra. But algebra is considered something that's hard to learn, and some things are really easy to learn. If you use these doors over here, everyone has used a door or an elevator to get here, probably. The stairs, I think, have doors, so if you're healthier than all the rest of us, we know you took the stairs. But some things are easy to use, some things are hard to use, but no, that's not true. So let's go back to the beginning, and we're going to go back not quite to the beginning of time, but we're going to go back to the beginning of education. We're going to talk some about childhood psychology and child development, which may be a weird place to start, but I think it works pretty well. And so we're going to talk about the Soviets, because why not? You have to have a reason to put a Soviet flag in on a talk. So we're going to talk about this guy called Lev Vygotsky. Lev Vygotsky did most of his work from 1926 to 34, and then he died pretty young. But to put this in perspective for psychology, Sigmund Freud hadn't died yet. So he died before Sigmund Freud. So this is the very beginnings of psychology, which really wasn't that long ago. Psychology is a very young science, really. And he had several thoughts and worked in groups. And most of his thoughts revolved around three kind of areas. Play, how do kids play? And why do kids play? Why do you play, even these days? We like to play games, we like to play things. How does thought and language come to being? Not something you generally think about every day, but if you have kids, you may be very much thinking about that. Or if you've had kids, as they learn language, and you move from wah to wah wah, and all the way up to full talking. And so he did a lot of research on that. And then the main thing we're going to talk about today is something he called the zone. Well, he didn't call it the zone of proximal development, but we're going to call it the zone of proximal development, which is what we're going to talk about in the first part. So we're going to do a first part, a second part, and then hopefully bring everything together. We'll see how this works. So the zone of proximal development tells us that just because you cannot do something doesn't mean you cannot do it. I know, wonderful statements like that. I thank Chris Keithley for making statements like that. So what does this mean? This means that Yoda's wrong. There is not a do or do not do. There's actually a whole lot of trying, and there's a whole lot of room in between when you can do it by yourself and when you can do it by yourself. So over here, you can't do it all by yourself. You think of a child learning to count. So first off, child can't count at all. And nowadays, you and I, when we can count, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we can count easily. But for a young child, they can't count right off the bat. Maybe they need to use their fingers. And so, or maybe they need some help thinking about what's next. And so kids work through this with aids. They maybe, their fingers, maybe they use little sticks or something, and so they think about it. And so that part where they're learning how to count, but don't really know how to count, but they're learning how to count, and they kind of know how to learn to count, is that zone of proximal development. And so there's lots of times where we involve ourselves in the zone of proximal development. When you're learning to play a new game on your iPad or your phone, what do you do? And there's this realm of where I don't know what to do. I'm going to try some things. I'm going to get some feedback, and I'm going to learn from those things. I may get some help screens as a walkthrough maybe on like a civilization building game. You'll get lots of little pop-ups that tell you, hey, do this next. And they'll walk you through some examples. And here's a good question. How many people can program? Okay, now how many people can program with a pencil and a paper? A few. So there's a few of you. Now, those of you who put your hands down, are you actually programmers? Can you program without the aids and the tools? Are you still in that zone of proximal development of programming? Is that a bad thing? Is that a good thing? We'll get to that later. And here's a good question. Can a 6-year-old learn to do algebra? Maybe. Let's see an example. So this is an app that came out recently that my daughter, who's now 7, but she was 6 when she played it, had a lot of fun with, called Dragon Box. And so Dragon Box, the game is really simple. You've got this box here, and you need to get it alone. So you got this bar in between. You got 2 spots, and all you need to do is make sure this box sits by itself. And it moves from that to this. We got we got a few numbers and some kind of equation-y looking things. And it slowly helps the child to get all the way to this. So here we got some this actually starts looking like math, all the way to, at the end, after about 4 hours of actual gameplay time and minimal interaction between my wife and I and my daughter, suddenly my wife looked down and my daughter's doing algebra, or at least symbolic algebra equation balancing. You know, it's not all algebra, but that's a lot. And that was with very minimal interaction from us. And so what's happening here is the zone of proximal development is moving up. So you might have seen, if you've done this is from The Art of Game Design. And this is actually from talking about the flow channel. And if you've ever read the book, this isn't the final chart. The book's pretty good. You should read it and see the rest of the charts. But there's this idea that the zone of proximal development, which here is shown as a flow channel, is kind of growing. As you learn things, it's going up, and you know more and more things as you go along. Here's the stuff that you don't know, that you just can't do. And so some people will look at games like this and say it's just gamification. You're not doing anything special. You're not really teaching the kid anything. They're just playing a game, right? Well, maybe. And maybe not. So a lot of it's actually structuring these, what's often called scaffolding. And some American psychologists, without too much knowledge of Vygotsky, in the 70s, came up with the word scaffolding, building these structures so that you can know more as you go along. And so it's really all about, here's part 2, the mental model. So you're building this model. But when we talk about mental models, first we got to visit a teapot and a stove. And so we're going to talk about this teapot. And this man, Don Norman, any designers in the place should, yep, I see some nodding their head. The design of everyday things, this is the revised and expanded edition. If you haven't read this, even as a programmer, I suggest you do. And hopefully what you hear will inspire you to read it. But you see this teapot here. This is a useless teapot, right? You can't pour it without pouring it on your hand, or you're going to likely burn yourself. And you have things out there in the world like this stove. So all of us have probably encountered a stove in a rental or something. This knob right here, which burner does it turn on? You don't know. You can't tell. Or any of these burners. You know these two probably go with these two. But back and front, which one's which? I don't know. I burned up a coffee cake because of that once. It was very sad. And you have doors. Like, you think doors are easy to use, but take a look at these doors. You have handles that look like they're meant to be pulled, and yet they're telling you to push. In the background, you actually have breaker bars that apparently you're supposed to pull somehow. I'm not sure how that works at all. And you see this a lot. You'll see people run into a door and they'll play with it for a minute. You and I have probably easily done that with various doors. And so what it is here is, in order for smooth operation of these things, Don Norman proposes this idea of mental models, which I think is a lot like the zone of proximal development when you're building these mental models. So a good mental model, if you understand how something works at some level, it's going to enable you to have quick learning. You're going to be able to learn how it works really quickly. Like a door, if you can see a push plate, you obviously can't pull on just a plate, and so it's obvious you're supposed to push it. That helps you figure out a model and then learn quickly that you push. It enables what we like to call discoverable features. Everyone likes discoverable features. What makes a discoverable feature? It's a feature that works within the model that hopefully you've taught the user. And good mental models are also flexible. They're able to take in new data, which helps enable those discoverable features. And they're also reusable. And so we talk a lot about reusability. And so, for example, we have a mental model of chairs stacking. So pretty much everyone here can figure out how these chairs stack, because you've likely run into other chairs that stack. And most chairs stack in the same way. If somebody does it slightly differently than what you're used to, your model may be wrong, and you may not be able to stack those chairs right away in a nice, smooth stack. And so you have maybe a bad mental model. A bad mental model leads towards simple, frustrating mistakes. And so I want us all to think for a second about maybe a grandparent or an older friend who has trouble using a computer, or even a younger person who has trouble using a computer. And so they haven't developed a very good mental model, and so they'll get small, frustrating mistakes, just little things that are frustrating, and they'll build up to sometimes random errors. I don't know why I lost my document. It doesn't always happen, but if I, tap on the table 5 times, hopefully it's saved. And you sometimes, and I've seen this in some people, where you get complete confusion shutdown, where someone just is so confused about what's going on, they're afraid that whatever they do, they're going to lose their document, their entire life story that they've been typing in, some little text editor. And so they tend towards some exact procedures. And so if you've ever spent time in IT, and someone comes and they ask you, how do I do this? And you start to tell them, and you're like, what are you writing? And they're like, I'm writing down exactly how to do it. Because they need those exact steps in order to make sure that they don't make any mistakes, because they don't necessarily understand the bigger picture of what's going on. Classic story, the blind men and the elephant. How many people have heard the blind men and the elephant? Okay, a few people either haven't or aren't raising their hand. The blind man and the elephant is an ancient tale. You find it in most cultures. And it's the idea of these, let's say, 6 different men, blind men, go out and they run into an elephant. And one grabs the ear of the elephant and says, oh, the elephant's flappy like a leaf. And one grabs the tusk of an elephant and says it's strong and sturdy like a pipe. And somebody grabs the tusk, or the nose, the trunk, there's the word, grabs the trunk and says it's like a snake, obviously. Elephants are like snakes. Someone grabs the tail and says it's like a rope. Someone runs into the side of it and says it's just like a wall. And so are any of those people wrong? No, but they also aren't right. They don't have the whole picture of what's going on. Collectively, they have a decent idea of what the elephant is. And in some ways, that's actually what we're trying to do here with how do you think? Well, we may really, in how you think, only be touching the trunk. But hopefully that helps us understand a little bit better of a picture of the whole, hopefully without also developing into a bad mental model. So we have these mental models, and we have this zone of proximal development where we're learning. And together, in the zone of proximal development, we're creating a model. And that's a critical part of the learning process, is building this model, a model that you may not even consciously realize that you're building about how something works. And lots of things go into building a mental model. You have social things around you. So, for example, someone might tell you how something works. And YouTube has been great for that. Everyone from Randall Monroe to Smarter Every Day to Minute Physics. But also there's some social, things you don't do. For example, you generally, in America at least, you don't drive on the left side of the road. You drive on the right side of the road. And so if you see a street and you see someone driving towards you on the left-hand side, either you're wrong and they're right, or they're right and you're the one going the wrong way down the one-way street. There's also visual cues, signs, things that tell you specifically, like the push sign. And sometimes you have to have push signs to tell you, why do you push? You have constraints. If you have a flat plate on the door, you can't pull a flat plate, so you're probably going to push it. You have also this feedback loop. This is the easiest way to explain this one is when you're driving, right? Especially if you're on a go-kart. You turn the wheel and you turn. You push the gas and you go. You get immediate feedback about what's going on. And these things all build into a lot of interface design, but also this idea of learning. So as you're teaching someone else or as you're learning, it helps to look for constraints, to bring these kind of sometimes subconscious things into the conscious level and think about them. Wait a second, does this work? What's going on here? How can I mentally, consciously help build my mental model? And let's put it this way, it's okay sometimes to stay in the zone of proximal development. You don't have to build a perfect model. For example, regular expressions. I don't end up using regular expressions very often, and every time I need to do a regular expression, I have to go look it up. So occasional usage is a great reason to not worry about getting out of the zone of proximal development. Just because you don't have a perfect model, if you think about Newton, so Newton's various laws, we know thanks to Einstein and quantum mechanics, Newton was wrong. But is Newton still helpful? Oh yeah, he was very helpful for a very long time. And still, today, most things really, we don't have to care about what happens when you're going 99% of the speed of light. And so sometimes it's okay to stay in that. It's okay not to have you don't have to have a perfect model. And sometimes it's not. And sometimes if you don't have a good model, it can be slow. If you had to look up every single method when you're developing a program or every single function that's available to you in the standard library, it would take you a while. And hopefully you'd learn those things. You aren't just going to forget them as you learn them. And that it is slow when you're learning a new language or something to get that stuff right. But hopefully you get beyond that so you aren't slow anymore. It can lead to mistakes and bugs in software if you don't have that fuller picture of how something works. If you don't know, for example, that your air conditioner works a certain way, then it's going to be difficult to figure out why is the air conditioner not working. And so you have troubles understanding things. And I think this is the biggest one that's missed, is missed alternatives. If you don't have a model of how things are working, a good model, you can miss better alternatives than what you're doing. If you're, for example, if you don't have a model about, you don't know about, for example, how development environments work, then you might still be writing in Notepad. And you don't have any idea that this whole other thing is out there, and you're missing this alternative. And that happens, I think, far more than we give it credence. If you see two doors, you don't necessarily know which door to go into. You may miss the opportunity of going through the right door. But just because you don't have that good model is a kind of a sad way to miss out on things. So good mental models are reusable. Examples are wonderful to create, to help create good mental models. That also means examples can't be one-sided. You can't have an example that just touches the trunk of the elephant. You need to have examples that cover more. And so that's, I think, very important when you're teaching someone, when you're teaching your users, because whether or not you like it, your users are learning about what you just wrote, or even if someone's trying to use the library that you just wrote. Those examples are really important. And a little understanding. So if you know nothing about programming, it's very difficult to understand programming. But if you spend a few hours learning something about it, you may still not be able to program, but if you built a little bit of a model, it can actually go a really long way. And I think this becomes really important when you talk about outside experience. So a lot of times we don't spend much time necessarily learning about biology if we have nothing to do with biology in our job. But knowing a little bit about biology, you're going to create some models that hopefully are reusable in computer programming. If you think about the history of science, science used to be very divided. You'd have trigonometry, and you had optics, and you had these pieces and these parts, and they didn't really meet. And now we don't think about 7 sciences. We think about other science, and there's, optics is not just optics off by itself. It's included. But without crossing over those borders, you're not going to figure out what goes in between the two, what's reusable in one place. A great personal example for me is learning, I'd done object-oriented programming for a long time, and learning a little bit of Haskell, doing some functional programming, helped improve my object-oriented programming. And those are more connected. But in this case, learning some about psychology and about cognitive psychology, how people think, has helped me write better programs, has helped me think more about and really understand more about how neural networks work. And a lot of computer science, in the end, I think, is is right now especially coming out of biology, and even Google's new Go, AlphaGo, which just beat the grandmaster of Europe in the Chinese game Go, a big mark in computer science. It learned by learning from other human players. And so it figured out how to learn and then continued learning against itself. So learning from outside your experience, I think, can give a lot of input into what you're doing now. Just because something seems like it's disconnected, if you think about it in a model way and building a model of how something works, that can often, not always, but often transfer over into other areas. So everything's nice and simple, right? There's nothing hard. We can just quit right now. Everything's easy. You just build a model of it, and poof, you're done. Unfortunately, there's still complexity out there. And complexity, it comes in several different ways. What we're going to talk about is these two different ways. So this is a maze that a guy in China built. It's much, much larger than this. Very complex, very difficult to follow anything in the maze. And this over here, it's hard to tell, but this is a model of a jet engine made entirely out of Lego. So Lego is very simple, little tiny pieces, and you can understand Lego pretty easily, how they go together, what pieces do what, but you still may not necessarily understand this entire jet engine and how it works, even though it was built out of very simple, tiny pieces. And then there's the complexity where each individual piece, all these lines, are not simple. And so you have many, many models, many different models, all interacting with each other, creating that complexity. So how do we deal with complexity? Well, the easiest way for computer science people is a framework and understanding. And so you wouldn't build a complex program without a framework. Well, don't let your users hang out without a framework. Why should they turn around and try to use your program without some kind of framework? And so if you're dealing with very complex things, breaking it down, helping your users to build those mental models and get through that, if you think about them as going through that zone of proximal development as they're building their model up, thinking about that may help you to put in things that help your users to learn better about it, but also help your library users, your friends, whatever you're trying to do to learn that. But there's a problem, of course. If you use a mental model a whole lot, it will turn into something that's automatic. You don't even think about the fact that you have a model of how doors work or how chairs stack. You just do it. And so that doesn't, you have to take that and rethink if you're trying to teach someone or teach someone to use your computer program or your app. What am I forgetting about? What is my underlying models? Because I've already gotten to this high level of complexity, because I've memorized, and all these models underneath that allow me to understand this, all these things, I'm so used to them, I don't even think about them to build that jet engine. But if I'm still learning about how to use a Lego piece, I'm nowhere near a jet engine. So good mental models provide that foundation, which lets you build things like jet engines without quite as much trouble. And some complex systems are often complex because of how many mental models are in work. And if you have a lot of mental models that are interacting with each other, and you have to learn each one of those little pieces before you can understand the whole, that leads to a very complex situation. And you better start working hard and giving a talk on how that works out. So here are some references, because we'll post these slides up later. Are there any questions out there? Silence. No questions at all. Are there any examples that I've used in creating mental models that you can turn around and use? Yeah, let's talk about like this talk right here. It's a great example. So I started out, I had no psychology training whatsoever. I listened to a couple MIT lectures and then clept out of it in college, out of gen psych. I don't suggest that, but it works. And so I started reading a lot of things without necessarily trying to understand that super high level. I tried not to understand the jet engine and just pick up on the little pieces of, okay, I can understand how this works now, or at least one possible way. And I kept making sure that it was flexible. So knowing that just because I know this now, or I think I know this now, I know that a book later, I'm not necessarily going to think about it in the same way. And getting that kind of broad underlying foundation and then building up. The same thing happens, I think, when we go to learn a new language. You start off with, okay, what's same about this language and the language I already know? What are the differences? And we Google around to see, is there a list of syntax differences? And so we try to get all those little tiny pieces, especially in computer programming. There can be a lot of those little tiny pieces that deal with syntax and different ways of doing things in a different language, and try to get those, flesh them out so that they're no longer, if you know a language, you don't even really think about the syntax until your compiler throws an error. But you don't think about the syntax as much. If you're used to a C-type language, you're going to throw that semicolon in at the end, whether you mean to or not. Your brain just goes ahead and hits that key. So getting those things that were hidden and done with in one language and dredging them back up from the bottom and saying, okay, what's different? What do I need to think about to get that kind of underlying base? Does that help? Right, so what's the difference between learning something entirely new and something that may have some construct? I guess the best example of that would be like the hamburger icon. So you have 3 bars, and it means there's a menu button, and it does something to give you more options. That's a very common one currently in design, loved or hated or somewhere in between. But yeah, that's where it becomes difficult, and it's the question of, does your user already have that model in place? And it can be very useful if you know, for example, you're developing an app for a tech crowd or something. You can use that hamburger icon to entirely do away with the fact that people have to even think about what that means. But on the other hand, if you're dealing with a wider population, they may not know what the hamburger icon means. And so then you've got to deal with the question of, okay, I've got 2 groups of people. The one that knows this social construct that we've built of the hamburger icon, or for example, and then people who don't have any idea. I mean, what on earth, is it even a button? There's a lot of that, and you've seen a lot of back and forth. A lot of people have switched from using just an icon to using icon and text. But that's a very difficult problem. But at that point, it's a question of, do your users already have that model in place? And the great thing is that you can also think about it as, what models do my users already have in place? How much, I don't have to build the whole foundation if all my users already have this whole part, and I can just worry about this part over here. And so you can more quickly speed things up. Another way is you can use discoverable features, I think. I recently used Airtable, which is a Google Sheets kind of relational database GUI web app, for lack of a better way to describe it. And as I was playing around with it, I was like, I wonder if this works. And it did. And I'd go and I was like, I learned this model from Excel, or spreadsheets in general. I wonder if it works over here. And it did. They never told me that those things worked. But they assumed that their users had used spreadsheets a lot, and that if they tried to do this, they wanted it to happen in the proper way. And so they did a lot of work finding out what mental models are people already using, and then applied them to theirs. Even if it didn't necessarily make as much sense for it to work that way, they wanted to stay within that mental model instead of trying to teach you something new. Omar and then.
Well, you mentioned that when you were getting ready for this talk, what were some of those changes?
So I think the most of my changes were bringing a lot of things out into conscious mind. Sorry, I didn't repeat the question. You're asking what changes did I see in myself as I've been learning about these various pieces and parts. The main change, and this isn't really technically related, but is in my children. So I have 3 kids, 7, 4, and 2 months old. And so that's actually what got me reading Vygotsky and about that side of educational development. And then I suddenly was like, wait a second, this stuff is like this stuff I've been reading before in Don Norman's works. And so a lot of it's been in understanding my kids better, but also understanding others better. And so a lot of it's been more on that psychological side of I'm now, I think, better interacting with people who don't know something because I'm like, okay, I understand programming. And someone who doesn't understand programming, it's always that question of, okay, they asked me what I did today. Which level do I start at? Do I just put together a string of words that makes utterly no sense to them, or can I figure out a way to bridge the gap a bit better? But also just in, I think, writing documentation better. Not when I do it, when I do it. I do it all the time, yes. Every day when I write documentation, I think I'm writing it better.
Back to Yoda for a second.
Okay. Right.
And have this death grip.
So the question is when someone has a bad mental model, there's at least some likelihood that people will try to, almost conspiratorially, humans tend to do this. We like to stay with the model we have. If we have a model of how things work, we don't like it to change, especially if we feel that it's very fleshed out, whether or not it is. If subconsciously we think, hey, we've solved this problem, and they start getting contradictory information in. You're getting feedback that when I turn the steering wheel to the right, I'm going to the left. That's not how it works, but it must be just a bug. It's just a random occurrence. It's nothing special. And so that's happened. It's happened to me. I mean, we all do this, but a great example is, again, I'm going to fall back on kids again because it's easy. When something, your kids are changing all the time, and so when you're trying to get them to take out the trash or something like that, the methods you used in the past will suddenly stop working on you, just out of the blue. And that you have that time where it's like, is this a one-time occurrence where you don't like taking out the trash, or is this we need to switch how we ask you to take out the trash? And so that happens to me a lot in that case. How do you help people overcome bad mental models? There's a whole industry centered around that of advertising and politics, which we won't get into, which are dedicated to changing your mental model, whether it's right or wrong. But a lot of the best ways to do so are that instantaneous feedback. So you would figure out very quick if you had a car, if you learned on a car where you turned left to go left and right to go right, and you started driving a car that turned left when you went right, you would get instant feedback, likely also an airbag in your face, that you were wrong. And so I think that's probably that main thing. if you get that instant feedback. The worst thing is a delayed feedback. And Don Norman talks a lot about this. And if you have anything with a delayed feedback, it's very hard to learn why is something going slow. So like here, right now, I've got some feedback or some battery going bad. And there's a possibility that I can move this way, and the signal's bouncing off differently. But the feedback's not very consistent. And people are moving, air's moving around. We got various deflections. And so that bad feedback or delayed feedback, if you can get rid of that, that's probably the biggest hindrance, I think, to learning a new mental model and learning that yours, whatever you have, is incomplete or incorrect. All right, thank you all for coming out. Have a great day.